Hare Krishna. Now we are going to see the time complexity of the naive string matching algorithm in best case scenario. We do know that this time complexity computation never involves the execution time. Instead, we consider the basic operations which are involved in algorithm. When we talk about the best case scenario, we use the big omega notation, which is representing the lower bound of algorithms time or space complexity. Basically, it informs us about the minimum number of operations which are involved. So at least these many operations are going to be performed, and that respective time complexity is represented with big omega notation. As far as the string matching, naive string matching algorithm is concerned, we do have the n and m variables. N is representing the size of text, whereas m is representing the size of pattern. In case of this example, the pattern is veg, which is of 3 size, and the text, I am vegetarian and like to eat all vegetables. This is of size 46. Now what exactly we do? We are creating the text window of 3 size, and we are trying to match the character from the text window with the pattern characters. So here we have already written this program. So from that it is easier to calculate the time complexity in best case scenario. So in best case scenario, what you consider, these many operations are going to be performed minimum, not less than those the operations are going to be performed in case of naive string matching algorithm. So here this text windows are slided by single character up to n minus m plus 1. So basically when I is taking 0 value, it is ranging from 0 to n minus m, and in that we are trying to compare the characters from the pattern with the text window characters. So if the first character from the pattern don't match with the first character from that text window, then obviously this loop will be skipped and it will go for the next, and this will be continued till it reaches to the n minus mth text window. So these many operations are going to be performed in any case when the pattern characters are not matching with the text windowed characters. So in this case, the best case scenario provides us time complexity n minus m plus 1. And in best case scenario, where we do have the pattern which is of so small size that it approximates to n. So this best case scenario time complexity of the naive string matching algorithm is omega n.